Ladies and gentlemen, may I have your attention, please? Our keynote lecture will begin now. Sit down, please. Sit down, please. Ladies and gentlemen, distinguished guests, good morning. Welcome to the keynote speech of the PCST Suzhou Symposium 2024. I'm the host of today's keynote lecture, Professor Fu Junren from the Chinese Society of Science and Technology Journalism. There will be one keynote speaker, Mr. Jinwoong, Professor of Seoul National University, Academician of Korea Academy of Science and Technology. According to the arrangement of the organizing committee of the conference, there will be no discussion during the keynote speech, and the discussion will be held in the following roundtable. Let's give you our speaker, Professor Jinwoong. His topic is uncertainty and trust in science. How can we deal with them in education and communication? Welcome, please.
Thank you. Yep. Thank you very much for inviting me as a keynote speaker for this wonderful conference. I'm greatly honored. And my name is Jinwoong. I'm a serious science educator, actually, working at the Seoul National University, South Korea. Maybe I am the only science educator here, and a bit stranger maybe, but I strongly believe that the concern of the science educator are shared by the science communicator too. And the topic of my talk is uncertainty and trust in science. And these issues has come up as a very important issues for science education, and I believe that you too have this issue as a very important things to solve. Right. My talk will begin with some uncertainty issues and trust issues first. And then I will explain my own research, one of my research, which is a bit out of the scope of science education, but I'm sure that it would meet the theme of this conference too. And then at the end, I will talk about the relationship between science communication and science education and what we should do to work together. Yeah, I'm a little bit nervous. My English is getting worse every year, so please forgive my English. Yeah. I've done my PhD about 40 years ago in the UK. Okay, let's start with this question. When do we face with the issue of the uncertainty of science? Yeah. Have you seen this movie? It's called Oppenheimer. It's a new movie. I've seen also this movie. Which, if you remember this movie, which aspect of the cinema are the especially scientific? I think many scenes of the movie would be more scientific. But to me, there is one very important moment.
3 years, 4,000 people, $2 billion. If it doesn't go off, we're both finished. I'm betting on 3 kilotons. Anything less, it won't get what it is. What would Fermi mean by atmospheric ignition? Well, we had a moment where it looked like the chain reaction from an atomic device might never stop. atmosphere. Or was Fermi still taking side bets on it? Call it gallows humor. Are we saying there's a chance that when we push that button, we destroy the world? Nothing in our research over 3 years supports that conclusion, except it's the most remote possibility. How remote? Chances are near zero. Near zero. What do you want from theory alone? Zero would be nice.
Yeah. I've seen this movie, and at this moment, I think this is the spirit of the scientist, and the difference between the scientist and he's the military man, he's a non-scientist. So, you know, if you were the Oppenheimer, what would you say instead of near zero? I don't know. You may have your own answer. Yeah. Scientists usually never say it's zero. Yeah. They always come with some probability, possibility, with some numbers. And maybe this graph is the most important and famous graph in human history. We've seen this graph. One is without human beings interruptions, the temperature graph, and the other one is with a human interruption. There has many vagueness, and maybe according to my memory, until the end of the last century, even the famous scientists were curious and doubtful about the real trend of climate change. And nobody was sure. But it's how the science worked. And nowadays, we are more clear about the climate change and crisis we are facing. There is a cartoon, the communication between the scientists and the public. And the scientists say it's a probability of 99.5%. And which means they're not 100%. And the public say, oh, it's not the truth. So there is a big gap between what the scientists say, claim, and what the public understand, interpret it. So if science is so uncertain, why do we have to trust it? This is the following issue. Uncertainty, and trust or not trust. Why trust science? There is a book called, this is the title of the book itself, and she is a famous scientist, and the idea that science should be our dominant source of authority, which means that the source of trust, and it comes from the Western countries since the Enlightenment. Should we trust science? If so, on what ground and to what extent? That is a key issue, and you may have, as a scientist, have some answers to these questions. You may have a communicator. You also have some answers to these questions, but it's vital. There are various positions in terms of trust in science. This is my own classification. There is a scienticism which claims that you can solve all the problems with science. And they are trusted in science. They trust the scientists, and also they trust the scientific claims too. There is scientific skepticism. They trust the scientists, but not the claims. And the conspiracy theory, they don't trust the scientists, and they trust the scientific claims. And there is a science denier. They deny everything comes from science. So there are different groups of different patterns of in terms of trust in science. And trust comes always with the uncertainty. In science, there is a group of uncertainty. Some are from the, it's statistical. You cannot avoid the uncertainty. But sometimes there's an epistemic uncertainty, which is comes from the lack of information. And there are different groups of uncertainty, which is inevitable actually in scientific way. This is one of my students' master thesis, but she classified what kind of uncertainty when the student do the scientific experiment in the school. And there she classified it into 4. The uncertainty is inherent in the data sampling and measurement. This is surely the source of uncertainty. Theory and model generation itself has some kind of uncertainty too. And uncertainty in prediction and making, decision making also another kind of the source of uncertainty. And uncertainty is the very characteristic of human being. The human makes always the mistakes, is unintended mistakes too. There is the different range of scientific things. One is from the facts. Fact is very certain, but the people want to more than fact. They want to have some forecast or prediction based on the fact, and they want to have some projection in the future, and sometimes it's scenarios. What happens if this happens? What will happen? And then you have speculation. So, what we teach in the school is a fact, but the people, what they need is more than facts. And sometimes it's a scenario, sometimes even further than the scenarios. Why do people something? Is the next question is that as a science educator, we always try to persuade the people science is to be trusted. It's worth to trust. But sometimes you realize that people believe something, not the science, but something else. So I had a research on this in some very strange setting. Anyway, why people trust something other than science? And I look at the acupuncture, acupuncture, what we call in Korean chimsul, and the other one is 4 pillars of destiny. There's 4 pillars, your birthday, year, months, day, and hours of your birth. As a science educator, the guiding question for this study was why do we ask students to solve the global problems? Climate change and water pollution, which is global. But students, they are not specialists and science education, but they ask them to solve there's such a big, huge, difficult issues. Why do we do that? The second question was why the people are still unscientific despite of extensive science teaching and learning. You all as a communicator, you all aware of this. The third one is, should science teaching and learning be the same across the culture? I think this one goes to with the theme of this conference. And this is the issue of trust. And there's an issue in terms of issue of trust. You have someone to be trusted. You have some claims to be trusted. So the person who claims and the content to be trusted. And so if you trust scientists, you trust maybe them. If you don't trust scientists, and say anything. So source of the trust is from the people or the person and what he or she says. And also, usually science in general is a black box, and sometimes it's objective and is disconnected with myself. But science in particular, like building some recycle sewage recycle facility near my house would be very important for them. So whether it's science in general or whether it's science in particular is a matter in terms of trust. And there are 4 science trust-related aspects. Now I'm going to talk later on this one too. What about the acupuncture and 4 pillars of destiny? It's based on the yin and yang theory, the ancient China theory, and the 5 elements, which is very popular in China, in Korea, in Japan, and many Eastern Asian countries. As you can see, the Korean flag is very philosophical. It's what you call tegel is in the center, and the symbols is like heaven, earth, and so on. So East Asian tradition has a yin and yang 5 elements are so much culturally embedded. And this acupuncture and 4 pillars of destiny issue is true. And it came from the more than 2,000 years to Korea from China. And sometimes it became the one of the subject to become in the history to become a civil servant. Yeah. And now the acupuncture is practiced by the nationally qualified doctors in Korea. It's a regulation. It's a very high standard practice, medical practice in Korea, and also similar one. So, what happened? We had an in-depth interview, qualitative study with 10 persons who are very highly educated. Almost half of them are PhD, and half of them are STEM-based specialty. Yeah. And I'm sorry. The question like when you had, And this is their trust, degree of trust toward the acupuncture. It goes up or stays high. And why do you trust the acupuncture? These are the common features with the science perceived by people too. And the 4 pillars of destiny is similar. Some are very high, some are low, but some increase. So, because of the limit of time, this is the challenging issue from this study as a science educator. The demarcation issue from between science and non-science needs to be redefined or rethought. It's not very straightforward. Maybe 3rd category or 4th category would be needed. The nature of science, so-called Lederman 7 in science education, needs to be more socio-cultural and institutional factors need to be included in. The people-centered trust issue must be introduced. So, what we suggest, Professor Zhou, as we said, claimed that from left side to the right side, the science education should change. People-centered, people-oriented, context-centered, community-based. Right. I will skip this part, but in science curriculum, national science curriculum, in many countries, they contain the content aims about uncertainty in the education, science education. Like this, in the Singapore, US, United States, and Korea, and surely the China too. And you have a different degree of uncertainty when the students make a scientific inquiry, according to the levels of the openness of the inquiry too. Right. Let's talk about the science communication and the science education, the relation between. There are 4 different sources of trust. The science education usually takes all trust them. Yeah. They trust the scientific knowledge, they trust the actions of scientists, they trust the scientific method, and they trust the honest of scientific community. What's the position of science communication? I'm not sure. I think the science education is too simplistic usually. The science communication and science education are traditionally, they have different aspects. They are focusing on different groups of people. They have a different means, they have different aims, and they are talking about different kinds of sciences. And thus, they have a different kind of challenges in their jobs. Particularly, because they have a different kind of sciences, you may need a different kind of approaches. But what I believe is that according to the much extended scopes of science education and science communication, we share quite a lot in the middle, a lot common. Scientific literacy, lifelong science learning, citizen science, internet and new media, social scientific issues, and nature of science. These are all the issues are currently very popular topics in science education research, and I'm sure that the science communication research also are also interested in these issues. So, yeah, I will. This is the last one. Yeah. So what we teach in school is the established science, and how we teach it, because of that, is as if it is absolute and certain. And this is the problem for the education itself. What we communicate in society is the emerging science and technology, and how we communicate is as if it is sometimes all tentative and uncertain, which is also not very fair. But in this hyper-connected society and boundaryless world, the gap between the two, science communication and science education, needs to be narrowed down. The source of the trust towards science must be not in its certainty. Yeah, it's not in certainty, but it's a certain nature or process to reduce its own uncertainty. Science has their very certain process to reduce the uncertainty in a systematic way. We need to make more effort to demystify science in the school, at the same time to recover the scientific trust in the society. That is the trust, the relationship between trust and science, trust and uncertainty, and also the relation between science education and science communication. This is the last slide. Thank you very much.
Thank you, Professor Jinwoong. You brought us a very good report. The report has helped us a lot by bringing new insights and new perspective on how we deal with understanding and trust in science, in education and communication. I think all of you have benefited a lot. Let's thank you, Professor Jinwoong, again. And time is limited, so that close today's keynote report. Finally, I would like to thank Professor Jinwoong has made a wonderful report for us, and also thank all the friends present. Thank you. Thank you.